Today, it's all about Gaussian splatting with a desktop solutions. So how to do that? I prepared for you a 10-step process to showcase how you can just use a bunch of images, of course, multi-view dataset, or a video that you shot to create Gaussian splatting. And in this case, I will showcase two scenarios. The first one is from a trip that I did almost 10 years ago in Norway, in a super nice museum where I shot some images from the boat, and from there we will generate the point cloud and also the rendering. And then after, I will show how you can use Postshot software alongside other tools to create rendering for videos, and also how you generate the point cloud and what is its overall quality. So if that sounds like fun to you, let us dive right into the workflow. So as you can see, we have 10 steps to achieve what we set ourselves up to. All right, super exciting. Let's get onto the first stage by installing the Postshot software. So for this, there is nothing simpler. You just go on your favorite browser. So for example, here it's Chrome, and you type Dataset.com, and then you will arrive on this page, and you have a user guide, very nice, and you can download the software. Some warning beforehand, you need Windows for now, 10 or later, and an NVIDIA GPU, which is a GeForce RTX 2060 and above, or a Quadro T400 RTX 4000 or higher. This is very important. If you do not have that, I think you will struggle a lot to use the software. So first thing is grasp this kind of graphic cards to be able to use Dataset Postshot. If it's the case, congrats, you can move on to the next step by downloading the software. You save it, and then after that you just go through the installation process. So you click on it and you go through all the steps. So as you can see, I already have Postshot installed, so it will not allow me to reinstall it. But there is no trick here, you just go through and everything will work seamlessly. As you can see, afterward they show you how you can handle Postshot. You shoot a video with your camera, you train your Gaussian splatting, you animate and you render. This cuts down so much of the bulk of the setting up process that you needed before having this kind of software. And what I really love about that is that it's a desktop edition, which is fantastic. Today you have a lot of cloud solution like Luma AI and other ones, but it's always asks you to upload something, to have no hands on the process whatsoever. You just get a result, either it's good or bad, but you cannot tweak it very much. So it's always nice to have a desktop version of things. Now, getting back on our full workflow, this is done, and let's move on to step 2, download the dataset 1, which is images. So you will find just down below, or whichever place suits best, the dataset link with some images that I took when I was in Norway. That's come back a while back. Fantastic country if you have the chance to visit it. And I shot at the time, I was really heavy onto photogrammetry, so I shot a lot of different scenes, and this one in particular, I loved it. It was a little setup around the boat, which was magnificent. I loved the lighting and such, and I wanted to see how photogrammetry would behave with that. Now with Gaussian splatting, you get something which I truly love, is the ability to get some kind of rendering visuals with fine details like the ropes on a boat or things like this. So get your hands on it, it's not a lot, and just put it in a folder cozy on your little local drive. So as an example, if I go there in my data folder, I have a Norway folder, and here this is Vigeland, the name of the museum, and you can see the images that I took a while back. I will have to check which camera it was, but I love it. And you see with photogrammetry, this was really hard to reconstruct these little lines, and all the images were taken like this. It's not the best shots, but I don't know, there is a special atmosphere, and you can only imagine how VFX and visual companies will just get massive leverage from traditional workflow that they used to have before. All right, so let me close that and maybe explore a bit properties, explore a bit the details. So you see I shot that in 2015, almost 10 years ago, and on the HTC One at time. So it was still a good camera for the time, right? So that's the data set. Let's move back onto our workflow. And now that you have your data set ready, you just import that into Postshot, which is the step 3. All right, so we have first to launch Postshot. And this is exactly what I'm doing. So it's very simple UI or GUI. You have the ability here to import, but better to drag and drop. And after that, you can just start the training, or you can also start the training on import. And on the right side, you will see that some element pops up. So let me take all the images, drop it here, just reduce that, have Postshot open, and I will use best images. In this case, image count, I take all my images. But in the case of a video, you may have the ability to adjust how many images you want Postshot to sample for you. And after that, the max image size, you can leave that to 1600 pixels. It's already very good. And the camera poses, basically the position of each camera in space, right? You compute that from the images. It uses, I didn't find exactly what algorithm is used, but I have a strong hypothesis that it is call map, which is underlying for the SFM, structure from motion reconstruction, because you have the ability to inject call map poses directly. So I guess this is what it's used. And as far as the max feature per frame, you can go on to 10,000, 8,000 is already good. And here you do not need to adjust the splat density. You could have more points if you want, but I don't think in this case it's necessary. And here it's only if you have a black background that you can check that. Concerning the training, I think 30,000 step is a well-balanced possibility to get a good idea about the quality that you can expect. But of course, if you want to render something super sharp, going beyond 30,000 step is also a very good solution. So let me import. And now my computer is spinning. I don't know if you can hear it, but it's spinning rightly. And on the right side, you can see that there are 4 steps of camera tracking. And here it goes pretty quickly because it's images. And then once this is done, basically is aligning in real time, or almost, let's say, the images. And you can already see a bit the boat that is getting reconstructed here, right? And this is just amazing, in my honest opinion. And after having the camera tracking totally done, so he's starting to train the radiance field. And this is what he's doing right now. You have all the cameras here aligned and all the pose estimated, and it uses that to then train and render the radiance field. And already here, you can see that we are not even at 1,000 step, and now we are going on to 1,000 step, and you have something beautiful. There is this aspect that is almost like a dream, right? I don't know how to explain it. I'm a big fan of photogrammetry, so image-based reconstruction, and I love it to be able to generate a very accurate geometry. But here, I believe there is so much potential to use this technology just for rendering. And in a while, and this can go very quickly, also being able to plug that with the geometrical accuracy of photogrammetry to be able to reconstruct something that is beautiful and accurate at the same time, right? So what I'm going to do is leave it until it's 30,000 step and get back to you once this is finished. As you can see here, we have already 1 minute 20 elapsed, and you have 11 minutes to go, more or less. So let's check back in 11 minutes. And the training is done. I will press OK. You see training was stopped because the configuration step limit of 30,000 step was reached. Okay, so this is the result that we have. And as you can see, it is just plain beautiful. I love these little effects that you have within the lines. Let me maybe showcase some things. So first off, I will deactivate the radiance field, and you can see the sparse point cloud that you get from the structure from motion, right? So you can pretty much grasp the scene, but it's the base layer. It's densified, of course, but it's the base layer for the Gaussian splatting. Now, let me re-put it and get back on our horse. So what we did here is to launch the GS training. Once we imported our image into Postshot, the Gaussian splatting training was launched automatically. And now it's time to explore the results. And as you can see, it looks pretty damn magnificent what you have, right? So of course here I'm going away from the pose of the camera, but still here where we don't have, I think, a lot of overlap, we have information, and you can only understand or see how powerful this can be, right? To detail something that you can then use or integrate into a 3D experience. This is fantastic. And oh, I didn't saw that, but let me zoom on that. I love it. These are two very cool instruments. As you can see here, you have what looks like to be a theodolite, which is an instrument that we use when we survey to measure angles and distances. And here it's classical telescope. It's beautiful that you have that here. Surveyors use that. Nowadays it's more laser scanner and Gaussian splatting that could do the trick, for example, somehow. All right, so this is the result within Postshot. Now let's move on to the next stage. So it's time to generate a rendering, okay? What do I mean by that is we will create a path, and basically we will say, okay, the camera should move along this path in order to generate a smooth rendering, a smooth video that you can use to showcase your reconstruction or to showcase your object. In a sense, it's extending the set of 2D images through a post-process production, whereas people just can get it, receive it, and just play it and see what you did. All right, so let's move back into Dataset Postshot. So in here, to create a rendering, the first thing that you will have to do is actually to move a bit closer, maybe here I will move a bit away from the camera poses because else it's cheating. I will put my camera here and I will create camera. Now the second step that you do is you go into your actual camera here, okay? It's selected and you see the view. Now I will here create some keys. I don't know if I can move that up. I don't think so. No, so I will create some keys that will be some perspectives, some pose of the camera at a specific point, and then Postshot will interpolate the trajectory between these poses. So the first one could be this one, for example. Also, at this stage, you have the ability to adjust the rotation around the z-axis to have something maybe a bit more straight, which I like to have. And once this is done, you just create here an object key. Once this is done, you move, for example, at 50, and I will go there, and I will move also my rotation a bit like this, and go a bit like this because it looks very nice. And here I create my key. And now if I move from one key to the other, you see that it interpolates my movement. So you can continue. You go at 100 for now. I go pretty linearly because I like this effect. I will make a very nice rendering from here so that you really see the splat. This is just my personal opinion. And I will move at 150 and move away from that to something that is closer maybe to the pose of the images that we had, like that. And then to 200, where we are like this. And see also the full boat like this, yeah. And finally, move back a bit here, right, a bit like this, and save it. This is the process to create the rendering. Now, if I get back, you see the movement of the camera. It's not necessarily smooth, but I just wanted to showcase how you could do that. If you want to see the real speed, you can just basically press play, and it will show how the rendering will look like. So once the rendering, you're satisfied with it, what you can do is render an output path. So I will click here to open, and here I will go into rendering, and I will put boat Norway live, and I want to generate an MP4 video, and I save it, and automatically it will put your path here. The frame rate, I will leave it to 30 frames per second. It's fine for me. The image resolution is here, but you can adjust anything here. So the focal length, the sensor width, all of these elements, you can adjust them. For now, I don't touch anything. I will show you maybe afterwards what it does, and I will render my video just like this. So I get onto the first frame and I click on the render, and you can see that he's actually moving frame by frame, rendering each frame independently, and then creating the video for you. Beautiful. So here normally if I get into my data Postshot rendering, and if I double click into my bot Norway live, let me check, put it full screen, you see the rendering with the splats. It's beautiful, and all the lines. Getting these lines, I will just remake it again. Getting the lines of the boats with photogrammetry, that will be a hardcore work to do. That's just for the information. So this is fantastic. All right, so now what happens if, for example, you change the focal length, you see you get something more like this. And does it actually change? No, it doesn't change anything. So you need to actually handle that beforehand and save the keys in order to apply that. Okay, so that was the rendering of our boat. Now, what is the next stage? Well, basically, it's all about exporting the point cloud for you to see what is actually the underlying data that we have. So let me get back into Postshot, and you have the ability to go into File, Save As. This is to save the project. What we want to do is actually to export. All right, so I pressed Save As, and it just shut down the software for some reason. So I had to re-put the images, relaunch it, and as you can see, I stopped at 5,000 steps. This is something very good. You can start and pause the training, and it's not save as, but export that I'm going to do. And my export, I will call it Boat Vigelund. I hope I pronounce it correctly, and I save my point cloud. Okay, now I will get onto Postshot point clouds, and you have Boat Vigelund 340 megabytes. So let me spin Cloud Compare. And now that Cloud Compare is open, we just go through the workflow to see where we are, and exporting the point cloud is down. Now it's time to explore the point cloud. Okay, so this is where we are. So this is Cloud Compare, and this is our bot. I'm just going to drag and drop it, minimize that. And as you can see, you have this little window that opens, which lets me choose exactly which Scala field or which field I want to have, so XYZ naturally, and RGB, you see that we have all of that that is already inside of our point cloud, but I believe there is like opacity, scale, and rotation. So at this stage, I will just use FDC 0 for R, 1 for green, and 2 for blue. There is a way to import the point cloud really nicely within Cloud Compare. This will be for another time because it needs to use a Python project and thereafter just to set up an environment to be able to use it. So for now, just to be very quick with a bunch of software, so Postshot and Cloud Compare, how you can visualize the point cloud. So let's apply that. And as you can see, this is what we get. So right off the bat, we have an inversion between the Z and the Y axis. This is normal because in computer graphics and for VFX games, there is this inversion where the Z and the Y axis are inverted, whereas for geospatial coordinate, we always have Z pointing up. So we should have to normally reorient our point cloud if we wanted to use it correctly. So let me just do that very quickly. I go from the top view, and I will put my point cloud more or less like this, right? Select it, I will rotate, go top view, and rotate it more or less like this. And now on top view, I'm pretty fine. And as you can see, this is the point cloud. Okay, so this is a Scala field scale 0. If I go onto RGB, we have something which is a bit unnatural, but still we have some information, right? So you could actually use that for geometry comparison. If I were to take a measurement, like from here, I use this tool and I take a measurement between this point and the last point of the boat. It gives me a distance of 64 centimeters, which is pure luck because this is, I think, more or less how it was, if I remember correctly, but again, it dates almost 10 years ago. So it was a scale model, not a very, very small scale, but still a scale model. But you will have the ability here to scale if you had some markers. Okay, you could scale to have the scene correctly placed. So what I posed before is that you can still get information on this very tricky element. We have some noise, but not a lot. And if you were to use that geometrically, you have some kind of filters like here. You have some filters like the statistical outlier filter that will help you remove some kind of outliers, or maybe another one, the noise filtering, where you could say, okay, take the nearest point, like the 10 nearest point, and if you have a max error of 8 to just remove like far away point, this is how I will do a non-aggressive filtering. You should get most of the splats, because for splatting, there are a lot of points that are geometrically not sound, but are good for visualization. And as you can see, doing that, we removed or lost some information, but not a lot, which makes it maybe a bit cleaner. So this is the point cloud that you will get, okay? Now, back on our full workflow, I wanted to show you another thing to have a complete view of what you can get with Gaussian splatting. It's importing another dataset from a video. So in that case, let me go onto Postshot, File, New. This will erase this project, and in the folder below, I just added, so if I go there, garden, a very small video, 40 seconds of my garden. I just wanted to show a very tricky atmosphere. There is a lot of wind today, so of course trees are moving. There are a lot of elements that are impacted on a contextual capture. So what we do is we take the video and we drag and drop it, and this is where it gets fantastic. It's that it will cut your video and select only the max image count that you want. So here, out of 1197 images, you could take only the 100 best images. I will go with, let's say, 200 for now, and go here at 9K. And the splatter, I will leave it here, and I will stop the training after 5K for now, okay? I don't want it to move too long, or just to get an impression. So now when I click import, it will take longer, because what he's doing is actually splitting up the video into these images and selecting only the 100 that we wanted. And here we are after 5,000 steps. Let me zoom in to see what we have. And this is wonderful. You see already so much. And I mean, it's 40-second video, and you get a full scene information here. This is just plain amazing. Doing that with photogrammetry beforehand, it was not at all the same time, and you could not have this level of realism attached to it. So now let's check out also very quickly the quality of the point cloud. So if I do export, I took the time, I edited a bit, but basically what I did is exactly as before. So I created a rendering of my scene, and let's now see what we have here. And now let's check out our garden video to see kind of the rendering that we get from the video that we shot before. And as you can see, my path could be a bit better defined, but it looks like already at this stage we have a beautiful rendering that showcase spring in its beauty. Now the second thing that we want to check out is our data set, and specifically the point cloud that we exported. So normally house garden, let me put it here, and as before, use that for the color. Apply all, and our point cloud should display within a few seconds. It's not well oriented, and this is normal. As I explained, they invert the Y and the Z axis. And now let me check out the RGB fields. And yes, you have already a sense of the overall decomposition of the scene, which is beautiful. Now, another thing that you can do, of course, is try and mesh that and use a projection technique to return the texture, but I will not do that at this stage. It's just to show you that you can very quickly get a super nice data set from a 40-second video shot. Now, if I were to take a distance like here, this is 2.70 meters, so I need to divide that by 2. So let me take my, and the scale will be 0.5 in all dimension, and this will be more or less the correct scale. So now I could measure the table, for example, from here to here more or less, and we have a table which is 80 centimeters, which is right, and more or less everything is to scale in this context. So this is beautiful. And my little cube, then I could move it to a place which is a bit better. Let me put all here. And before doing that, I will make sure to rotate not my cube, but my house. Yes, and my box, I will delete it and I will fit a primitive. So file, primitive factory, and I will put a box of 1 meter by 250, right? And y of 2 meter. Create, close. So now we have what I wanted to fit, and my box, I will just slide it, not in Z, and have a rotation only around the Z axis to put it against the wall, maybe, and see how much space I would have left. So if I were to put that here, okay, and now I will have to slide it to the ground. So for that, let me check out where the ground more or less is. So I take my box, use that, and I translate this time only along the Z axis, and I think more or less it is here. So let me check. Yeah, I think it's here. Okay, so this is very rough. So it means that if I were to put now, let me put that against the wall, so like this. If I were to put something here, yes, and it's not flat, but that's normal. If I were to put, I don't know, like something to hit my office, then this is how much space it will take in my garden, or at least the back garden. So yeah, at this stage, I think you have a pretty good idea about what you can get at this stage from the Gaussian splatting from the second dataset video. So to summarize here, at this stage, it's wonderful because with only a few software, namely Postshot and Cloud Compare, you are able to both create beautiful rendering and have a sound geometry. It's not super accurate, it's a bit noisy, but you can do stuff with it. And I showcase also that you can use both photos, a photo set, of course it's a multi-view data set that you need, or a video. I didn't extend myself on Gaussian splatting principle or how to shoot a video or photos. This is part of the course 3D Reconstructor at the Learn Geodata Academy. And the next stage is actually to go through this various steps to create a web experience. And this again is through the course 3D Reconstructor. So if you want to push the current knowledge into something that you can turn into a product, I will encourage you to check out if this course line is for you, or take other course line around 3D deep learning, 3D data segmentation, and point cloud processing. And this is the end of this tutorial. As always, I try to push out depth-first approach that you can directly implement and put in place. If you want to see more like this, don't hesitate to comment down below. This is how the algorithm pick up some signal to say, okay, this is actually useful, and also what you would like to see next, and I will do my best to create something sound that works in your case. It was a blast for me. I hope it was for you. See you in the next tutorial. Bye bye.